RPCiege, attack, strategize, conquer. It's time to siege your destiny.
Welcome, welcome. We're going to be going through RPCiege games or skirmishes. They're skirmishes. 3 and 4. I think for 3 we'll get pretty close to a solution, if not an actual solution. For game 4, some folks are still working through that. I'm going to provide some helps. I don't know that I'm going to go all the way through to answering that quite yet, but we'll see. We'll see where we get and if people are still stuck. The hope is that this will record and that we'll be able to deliver this to the chatter channel later. Okie dokie. So let's just go ahead and start where all good projects should start, which is inside of the booklet for our skirmish 3. So we've got our contract hash, and then we've also got our contract code. So, and then there's a nice little hint that writing tests is probably going to be helpful. Obviously not required. There's lots of different ways to solve this particular quest, but I'll be writing a test against this. A good way to get started when you've got a new project, I think they've still got it here. Now, to be fair, I have not rehearsed or practiced this in a while, so we're going to be learning together. So pour yourself a cup of coffee, get yourself some popcorn, and enjoy the journey. So a good place to start here when we're setting up a new project, if you don't have your Soroban CLI installed, I know a lot of you all are using Gitpod, which is fine. It's not that hard to install Rust on your local machine, and it's usually going to be faster and easier to work with. So the setup has worked fine for me. I know I was very intimidated having gone through trying to install Python and Go, JavaScript, like Node on my machine. Those are all nightmares. Rust is a little bit less nightmarish in my experience. So give it a shot. If it doesn't work, you can always go back to the Gitpod. Next thing we're going to do is make ourselves a brand new project. So I just moved into the hello world. And I'm going to make a new directory here in my, just on my desk, on my desktop. Let's call it RPCiege workshop. And then I'm going to code insiders into this directory, and we'll shut this one down. We actually want to code insiders RPCiege workshop. There we go. Nice empty project. And we'll need to cd into that as well. And now we can run this command, which is cargo new library, and we'll make this project. We'll just call it the same name. Doesn't really matter, but workship. That should give us, oh, looks like it actually makes a directory. So now we've got a directory and a directory. So GG's, that's fine. Doesn't really matter. We'll just need to cd into that so that we have it at the root. All right. So that'll give us some boilerplate code with a lib directory, and that's it. We'll write a test inside here in a bit. You'll notice that I've got a Rust analyzer running, which is going to give me some of these like type definitions. It'll give me like tests that I can run. It looks like it actually puts a test inside of the library, which is kind of cool. So you can run those right inside if you're using VS Code right inside your CLI. That you can install if you go to extensions and then just type in Rust Analyzer. You'll get that. You can install that. That'll make your life much easier. Look at that. We have a passing test. Fantastic. So at this point, we don't really need to do anything else yet, but we can keep scrolling down. So we've got our cargo toml file here. It says you got to put some stuff in there. I think most of that already gets put in there for us. We'll go ahead and add the library definition. No idea what that means, but apparently it's required, so we're going to throw it in there. We need some dependencies for Soroban and the dev dependencies for running tests, and then features for those libraries. Get rid of that one and put that in there. You'll notice that it does some Rust Analyzer cargo checking on all this stuff, which is pretty nice. I'm new to this. I've got the chat thing for AI that uses this new, or not new, but the code insiders. So I don't have all my dependencies installed, but I have noticed that it's a lot faster than my typical one. So I probably have some weird extensions installed that have been slowing down my classic VS Code. So I've been enjoying working inside this new insiders one, but it is missing some nicenesses. Let me make sure this is big enough for everybody. I can see Raf over there squinting. Okay. Profile release. This is when we actually go to do a build before we do a publish to the FutureNet. We'll pop that guy in there. That'll give us optimizations for when we're actually making deployments. So it'll compress and blah, blah, blah. Some interesting things. We're not going to release with logs, so we don't need that one. In the end, it kind of looks like this, and this is kind of what it looks like. So it seems like we're heading in the right direction. So save that. We'll go back to our lib directory. File. And we're not going to be using the standard library because Soroban doesn't like it. Keep things small. We'll go ahead and import the SDK, which again, we don't really need to do all these things because all this is going to be included for us when we copy over our contract code, but just for the sake of following the example, hello world to the T. This is where we get especially our Rust test. So we'll write a test RS file and we'll pop this in because this is what we're really after for this particular example, is getting a test in here that pulls in our contract code and gives us a client to be able to interact with the functions inside of our contract. So I don't think we actually made this test available to us. I think we have to import it. I'm not sure if they do that here. Interesting. Well, I know you definitely need to write mod test to get the test. Maybe if it's in the same directory, you can get away with it. Looks like this. Oops. Look at that. We're debugging live some missing bits and pieces for our hello world, so we'll have to go through and fix that. We can run our tests. That'll compile everything, particularly given that we have imported our SDK now, and then also are not using the standard library. What is this squiggle? Snake case. Interesting. Must be something new to the Rust Analyzer. We don't need vector anymore. Oh wait, we still got a to-do in there because we haven't actually imported it. So let's this is the new full one. Ah yes, and then inside that we do actually have the test. And it looks like because we're missing the configuration flag here of test, our test failed. So now we should actually be able to pass it. Congratulations! If you get this far, you've already beaten Skirmish 1, which Skirmish 1's even easier because you technically don't need anything other than an argument for where to send your NFT. You don't need the contract to do anything, which is kind of interesting. All right, so that's our hello world. We can see we're passing in, or I'm sorry, we're returning this vector with the symbol of hello and then whatever the to argument is, which is also a symbol. So when you go and write your test, you can say I want to pass in hello dev, and I should get back when I assert the response of words. The words should be a vector of hello, which is what this bit is, and it should also be dev, which is what we passed in here. And so if that is true, our test will pass. And so if it was something like devs, that would fail because now it doesn't match. But if we change that to devs, it would, because those symbols are the same. Okay, but you're not here to learn about basic Rust contracts and tests. You're here to figure out how in the world do we solve this guy. Fair enough. There's a lot of different ways to solve this. I'm going to go ahead and copy this. I'm going to try and copy this, see if it is actually valid code. That looks disgusting, so we are going to run cargo format all. There we go. Okay, so we've got a new contract. The only function in here is game 3, so this is probably going to end up broken because we don't have a game 3. Let me go ahead and do a mod test, and then we also needed to include that config test flag. And now our test should be broken because we don't actually have a hello function on this anymore. But the rest of this is all valid. So let's get rid of this. Let's do client, and then we do dot, and it looks like we have a game 3, which is going to be passing a symbol and an NFT destination. All right, so let's take care of the NFT destination first. And because this is a test, I do not care where it goes. So I'm just going to write a let of NFT destination equals, and we'll make this an address, which is just a random address. Looks like we need to import address, and random is a test utility, so we'll need to import that. And I think that needs to be coming from a test utility. Since we're calling address in 2 places, one is a type and one is a test, so we don't actually need this to be a type we can call. We just need to import the address. So let's get that in there. Let's get rid of these unused bits for now. This needs to be borrowed. Okay, so now we just need the impossible symbol. How are we going to get the symbol? So if we look at let's look at this one because it'll be easier to see. Let's look at our contract code and just kind of walk through what's happening. So we've got our NFT destination, which is just where's your NFT going to go, and then with the symbol, this is what we're looking for. We can see right off the bat that if the symbol has been stored, already used, we're going to get a used PU error. All right, and then we go into here and we start collecting our bytes. We build this new bytes off of the symbol. So the symbol is going to come in. We clone it so that we can end up reusing it in other places like here. And then we call toXDR, which is going to give us a bytes array. All right, well, that's interesting. We're then going to hash the bytes and give us a bytes n, and I'm guessing this is probably used once we've hashed that. That's what's going to be used to look up whether or not it contains the 112, 101, and 119 integers, which when translated is PEW. Interesting. So basically it takes your symbol, hashes it after turning it to XDR, and then it's going to loop over your hash and look at index 0, 1, and 2 as it goes through that U30 or the bytes N32. So there's 32 characters in a SHA-256 hash. It's going to look at each one starting at the index 0, and then it'll go 0, 1, 2, 1, 2, 3, 2, 3, 4, until it finds a match for PEW. If it finds one, has PU is true, and you pass the test. it will have pew, and so it will store your symbol. That code will have been used. No one else will be able to use it. Otherwise, you get the infamous missing pew error. Okay, so the brute force piece of this is to somehow figure out, okay, well, we need to be able to find a hash which contains the somewhere in its order 112, 101, and 119. And we can arrive at that by generating, somehow we have to build a symbol that once hashed after converting it to its XDR format. After we convert it back to a hash, we can get that order. So to write a test for that, essentially all we really need to do is just let's make a new test. This one isn't actually going to be testing anything in the contract, so we don't actually want this to run all of the time, so we'll ignore it. And then we're going to write a function for generate a pew symbol. And so this will be the function that will output a pew symbol, or at least that's the idea. Now again, there's a lot of different ways we could do this. I definitely went hard mode. But I'm going to try easy mode this time, because essentially all you've got to do is generate a valid symbol and just be able to generate loads of those. Basically copy this same logic here. So we'll just copy this right into our test. And somehow we have to generate a symbol so that when the symbol gets passed in, we can run the exact same logic and say once we get a pew, we stop and we actually return that symbol. So let symbol, this is the piece that we need. And then we're going to grab that symbol. I don't even know if we'll need to clone it because we're not going to use it ever again, but potato, potato. Convert that to its XDR format and then get env, which I think means we'll also need to make sure we actually have the environment available to us. We'll grab the symbol. We'll convert that. We don't have that bit yet. So if we let's just, for sake of example, we say, let's say we've got this. So it's we'll create a new symbol with the environment and the just an empty string. Imagine if that worked. That would be amazing. And so we run through all of that. And then maybe we do like a print line. And we'll just output what the symbol was. Or maybe we actually need to output the has pew. So we run that. That's going to throw some errors. Oddly enough, it's not telling me where those errors are coming from. I definitely know it has them. Okay, so we got that print line error. That's a good place to start. So to be able to get print line, we'll need to use our standard library, which again, we're in a test and we haven't done. You could actually, pro tip, you could do this in your actual contract because we're not actually going to deploy this. We're just trying to find pew. You could remove this standard flag here and be able to use all the standard stuff. There's nothing that says you can't, but since we're in a test and this is a better place probably to do it, we'll put it there. And then we also need to make sure we have the standard library crate. Okay, perfect. Got rid of that error. And now we've got symbol that we're using. And this, I don't know if that'll throw or if it'll let us run that test. 2XDR is not found in symbol. That's because we need, I'm surprised my My Rust analyzer is not. I wonder if it's because it's getting caught up here on my symbol. If I do that, does it? Yes, perfect. Because it's really nice to have these squigglies, because a lot of times they'll have a quick fix. And I know for a fact that what I need to do is import this one, which is this XDR to XDR bit. Okay, try and run that test again. Perfect. Has PU false? Well, unfortunate. But this is the basic idea, because now what we need to do is start looping over all of this and say, while has PU is false, we just keep going. And so I'm going to make a, let's do a while not has PU. And we'll just keep looping that over. Now, has PU, I think, is defined here. We need to get that outside of the loop. I also know that this is going to need to be mutable, because we're going to be changing that. The rest of this, I think we can kind of keep the same. Now, fair warning, this is a very dangerous while loop, because you will get stuck in an infinite loop if you've written your code in such a way that it will never find a PU. So if we were to run this now, it would definitely get stuck. So let's add an iteration variable here. I'm just going to put this here so that we can keep track of our iterations, almost as more of just like a sanity check of sorts. That will essentially say, let's just print out the number of iterations that we've gone through. And in our case, this will print out once every 10,000 iterations. And maybe we'll also need to increase our iterations. And then maybe if we get to a if iters is greater than or equal to, I don't know, that many, will break. I'm not sure if break goes to the next loop or if it actually breaks the while loop. We're about to find out. Let's see what happens when we run this. Lots of errors. Oh, I bet I know what it is. CPU limit exceeded. Drat! What we're going to need for that one. The really nice thing about running tests inside of the environment, the Soroban environment, is it behaves very much like the FutureNet or the actual Soroban network will, including all of its resource limitations. But to heck with resource limitations, let's set a budget for environment that is unlimited. The full force of my machine unleashed on this problem. Let's see what happens when we run this again. Okay, we're starting to loop through, and we obviously are never going to find a symbol because we never actually change our symbol. And then we broke. Good. The break does actually break the iteration at that 100,000 iterations. Very nice. So now all we have to do is figure out a way to just start creating random symbols in here inside of our symbol bit here. So somehow we've got to figure out how to maybe grab a hold. See how we're doing this? We've got a mutable iterator here, which it doesn't look like anywhere we're actually actually I think we use the iterations, don't we? That would probably be the better thing to do, because that loops over this particular mutable helps us look through the actual hash. The symbol iteration that we're trying to change here, this one, probably what we need to do is use our iters because this is going to loop through each one of these. And this is what we're going to want to use as some sort of seed for the symbol. Now, the way that I wrote it was using a completely different mechanic for this. I actually just generated random strings using an RNG generator. But I also know that there's a way to do it where you just use, in this case, the iterations of the while loop that we're increasing by 1 every time we loop over and look. But I don't have that code available. So if someone who did use this mechanic, who's listening, can paste me some code for how I can do symbol equals symbol new and somehow get this to include the iterations. That one says iters to string as string. Does that work? I don't know. Maybe it does. No. Alloc string to string. Still broken. String from. Symbol, okay, I've got some code here. Symbol, new, string as string. Let's see if that works. Isn't that what I just tried? No, it wasn't, because I didn't have the environment included. So we need to take iters. Oop. It might be .clone. Okay, why is this not working? Can't call method toString on ambiguous numeric type integer. Well, what if it wasn't ambiguous? No method named toString found for type U32. What else we got? If so, is your oh, if I did it on I32, maybe I64. Nope. Any ideas? I32. Yeah, so why isn't that working? Maybe my toString thing right here is, oh wait. Do you use the alloc in there? Because I don't, I'm using it, but I don't, let's try and include it in the extern. Oh, look at that. Magic, when you clear out the errors, things begin to work. Okay, so now we're using iters to clone to string as string. So let's take a look and start looping through this one. I think we're setting symbol, oh wait, hold on. We have sent symbol after it's being used. So we need to change it before we use it. Classic. Let's try that again. The best part is when you like write some code you're pretty confident in, and then you go through one of these brute force things and hope that maybe you've figured it out. Only to come back 30 minutes later and it's still going. Okay, that didn't, I'm not sure that it didn't work, but what we're not doing is making sure that we're actually getting new hashes, because at the end of the day, what we really need to make sure is that we've actually got new hashes. So I don't want to print out every single time, or that will be an infinite number. Let's do this and say the hash. Let's make sure we're actually getting a new hash. Indeed we are. Those are new hashes. So that seems it seems good. So let's just remove our limitation here, our throttler. We know we're getting new hashes now, so let's just keep printing out iters, and let's run our test. I'm not checking if haspu is true. I am checking if haspu is true because it's doing a while loop on it, right? So if haspu ever equals true, it should break the while loop. Maybe. Or we can sit here for 30 minutes and see who's right. It would seem that after maybe 30 300,000 iterations we would find one, but let's keep going and see what happens. Indeed. Indeed. We could also, I don't want to include that in there. Just for the fun of it, in the case that I'm wrong, if has pew, let's print a line that says, let's just do this exact same one here. And we'll get ourselves a print. Kill this, run it again. And if we ever find one, it should print for us. Yeah, don't start from zero. You'll need to... Robert has made sure that this will not work for the first 2 million loops. I think you can... What you could do is instead of using a while loop, to use a for loop. Isn't there a way in Rust to like invert the index or the index to go down instead of up? If you do something like... I don't know. Isn't there like a U32 max and then you do ... U32 min, something like that? Wouldn't that go backwards? I'm not actually sure if that's true or not. But there is a way you could invert it. Hey, we've been running for 60 seconds. Let's go. Still no answer. Wonder if it would be helpful to add more entropy. Regardless, I will say that the code that we've written, this should get you there. Whether you need to add a little bit of additional here or break your loop, I feel like the check is correct. But maybe we're messing up with our check. But the hash is different every time, so that's the goal here, to make sure your hash is actually different. I am surprised that this hasn't caught anything yet. How about I copy this code or this particular test? I'm having a little bit of a trouble seeing it. I'm going to paste this in chat. All of our big brains can take a look at it. Oops. I know the one that I use has more entropy and has... I don't know if that, like, it's just not going 0, 1, 2, 3, 4 all the way up. But it's at the end of the day, like, it's a SHA-256. We found one. You want to know the best part? We didn't actually log what it was. We just logged that it was true. But that's fine, because otherwise you would all have a key to cheat with. So was it intentional? Absolutely. So now you've got code that works. And I will leave it to you to take it from here and actually find a code that's valid. But this is how you loop. This is how you brute force SHA-256 hashes in Rust. Thank you for coming. Now onwards to skirmish number 4. Okay. So this is what we were given. That's tiny. This is what we were given for number 4. Nice big good luck sign. So we've got our contract code. We've got 2 functions. And then we've got this nice little snippet of information. And I have begun including along with this, I'm going to paste this little nugget, which I'm going to include in the booklet later today. This little guy here, I'm going to paste it in chat, but it's, there we go. This little bit here, which is, this should be helpful for figuring out what's going on, but let's go ahead and walk through it. And most of this is going to involve the CLI and the RPC. So we've got a little, just the Soroban CLI flag here. You probably use this a million times. The big one here is that you can include help things, which can be helpful for figuring out the function names and arguments that particular contracts or even functions take. So let's go ahead and do this. Soroban contract invoke. This is probably really tiny. ID. This is the contract. Our source, I have a default account, which if you've not yet used these Soroban config help, you've got identity and network. So you can set up your own identities. And that's what I've done with this default. I really like to use the -- global flag so that anywhere my Soroban is showing up, it's not localized, but it's a global default. So I have that enabled for both my source accounts, my identity, and then also a network. I've set up a couple of networks. So I can do network RPCiege live, which is the RPC for RPCiege. All right, and then we'll just hit -- and then -help, and we get those two functions, get and set. I'm going to make the outrageous assumption that get should come before set, and let's see what this takes. I'm sorry, set would come first. I did make an outrageous assumption. It includes nothing except for a source flag, so we will, our argument. So we will include a source argument, which I actually want to be the, if you include source, so if you included this source as any random address, you'll get a authentication error, so it will need to be the same source as this account. So we'll get to use this guy again. Identity, I think there's an address flag or argument global, which will give us that, which is what we'll use for the source. And that appears to have called successfully. We get no response, but that's a good thing. Now, obviously, that's not tremendously helpful, though, so we kind of move into, I write these relatively carefully with the idea of including keywords that will end up being helpful, as well as the most essential links. The big key one here being this Soroban events. Now, I know I included 3 dots, and I kind of did that on purpose because I don't like including versioning that I have to constantly update, which will eventually get out of date. So pro tip, you can just go to Soroban tools, and then we look up for whatever this Soroban CLI full docs are, and then it's looking for something with events. These docs are insane, by the way. They're all auto-generated. Looks like that doesn't, it's interesting, it doesn't just jump down the page. Seems like a bug with GitHub. All right, so we've got this Soroban events. Let's just go ahead and call that and call it with help and see what we've got available to us. You've got some options, some filters, testing and options. So we know we're definitely going to want to call it on our particular contract hash, which is this one. And we know we're going to want to call it on the network. We could do RPCiege. I'm just going to do FutureNet. They're the same basic thing. Looks like we're missing some arguments. Start ledger and cursor. Let's do a start ledger. Start ledger of 0, that's not good. Start ledger of 1. Start is before oldest ledger, so I think there's probably something wrong here with the ledger. And if you think about it, where do we want to start kind of is asking the question, how far back in time do you want to go? Either there isn't a ledger 1 for the FutureNet, or it would be getting too much information. So it could be like we would need to include a count to limit the number of maximum events that were returned. But regardless, if we want to find a valid RPC, a valid start ledger, we can go over here. There's another hint inside the get ledger entries, which is really just well, that'll be very important momentarily. But really, you've got this concept of just the RPC docs. And so yes, we will be doing some work in the get ledger entries, but most importantly for our purposes, we need to get a current ledger. So we've got our latest ledger. We've got some request information here. Get latest ledger. So I've got my Postman open up in the other window. Let me make sure if I feel comfortable pulling this over. There is a Postman collection for the Soroban RPC for folks that use Postman. That will be linked later, but regardless, you can use curl. It's just a post request with this body, but I've got it right here. I've got my Soroban RPC set up to just the FutureNet right now. All right, and there's our sequence number. Now this is the current ledger, so we know that when we sent our event, it was probably, or it definitely, was not in that one. So let's back up by a few. So we'll just take off that 7.4 and do 0.0. Look at that. We've got an event. It comes from the contract that we specified, and we've got one value, this event that was output. We've got the value and the topics. So the value is this bytes, smart contract bytes, this bytes M, and then that M length will be determined by the number of characters. So we've got this one, and then we've got this one on the top. So let's just copy both of these for now. And we'll call this one, this was the event value. And then we've got this topics one, which no idea exactly what this is, which what else could it be except for some other key. So this would be the event key. But these are the only two things that are given to you inside of this. And this is where this code that I pasted inside the chat comes from. Where inside of the contract code that this contract, the F47 contract, there is a bit there that actually sends the event that we just saw, and then it also sets the storage. So storage and events, those are what we're looking for. And since this is the only other piece that's given to us, we can kind of safely assume that this will be important when we go to look up our storage. Okay, sweet. I think another thing that's probably pretty important at this point is to look up, might be helpful anyway. Let's just look up what Game 5 get is. Let's see what we're dealing with. All right, we got a bytes event and a bytes store. Well, it looks like we just found bytes event, probably. But we need this bytes store. So we're going to need to figure out, okay, it looks like something was stored in the contract somewhere. And then obviously the NFT destination and the source again. So really, I think all we're looking for is probably the value of some key inside the store. So I'm going to make the assumption that this event key is probably the key of the store that's holding the value, because that's the only other thing we've got. Maybe it was hidden somewhere else. But because there is a value, probably safe to assume, let's start there. Good idea. Love it. But how in the world are you supposed to get values out of the chain? Another excellent question. Let's take a look at Soroban. Soroban has contract and config and events and other things. So we're looking for contract data. So let's use Soroban contract data, bindings, deploy, inspect, install, invoke. Ooh, print the current value of a contract data ledger entry. Amazing. That's exactly what we want. Oof. Currently, it doesn't appear as though you can actually read this from the live network. We've got no network flags, no source flags. This is all just going to be for the sandbox ledger file place. So I have a request out. Maybe I'll link and get a bunch of love on so we can push for this. It would be really nice if this contract or this CLI command, you could include network and source to go in, or at least network. I think I would be always just reading information. You don't need to sign it. A network flag for going and getting contract data from the contract. So unfortunately, that's a no-go. So let's go here. Get ledger entries. Back to the RPC. This is RPCiege after all. Okay, we've got a get ledger entries. So inside the RPC, we've got get events. That's not what we want. Or health. Hopefully it's healthy. Get latest ledger. We already got that. Network transaction. That might be helpful, but probably not. Send, no. Simulate, no. So this one's the obvious choice. Get ledger entries. We can read through all of these bits. But essentially what we're trying to do is say, I want to get the value. If given a key, I want to return a value for that key. Oh my goodness, I don't think keys, let me check something. This might be a wonderful moment. Oh no, I do think keys is an array. Okay, good. Previously, keys was not an array, and so I was fearful. Well, we'll try it, and if it breaks, then I will profusely apologize and get these documents updated. But let's go ahead and give this a shot. As written. Okay, so we need a key in order to find its value. Well, fantastic. We have a key. But that key looks nothing like whatever that is, XDR. So I guess maybe we need to convert the key into XDR. Well, that's probably where some of you went without reading further, because there is a nice little block here called generating key parameters. Now, rip to anybody that tried doing it in Python, because apparently that doesn't work. I don't use Python because it's an inferior programming language to every other one known to man. I use what every good developer uses, JavaScript. Which, to be fair, I don't think this one works as written either. However, we are going to use JavaScript. I'm going to create a new one of these, and I'm going to open up a run kit, and then I'm going to pull this back. I just want to make sure I don't leak anything else. Okay, so copied this and pasted it in. Okay, we can do some reading. We don't need to request an account. It's always good, I've found, to read, kind of just peruse a whole document, particularly like the headers. We know we don't want to request an account because sometimes like secret important information will get buried somewhere. Requesting a contract's WASM code. We don't need to do that. So looks like we're good. What we need to do is get a key to be able to call the value. All right, nice. So let's go ahead and do that. That looks like a contract ID. Is it a contract ID? Contract ID, yes. Okay, so that's not our contract ID. Our contract ID, as given to us by the booklet, is that. And then if we run this, we should get, something that actually looks like XDR. And then we take that, we go to our RPC caller. We put in our key, we put in this, and we call it. And we're going to get entries null. There are no entries, and that's because there is no counter key. Okay, well, rad. What would our key be, I wonder? Maybe this. Okay, sweet. Let's put that in there. Amazing. We've got XDR. We've got a key. We've got our contract. We are absolutely cooking with gas. Let's paste that in there and send it. Cannot unmarshal key value at index 0. Well, thanks XDR for being so XDR-ish. We really need to find an acronym for XDR that is pain and suffering, because that would be nice and helpful for things like this. Because that's not what the world does unmarshal key mean. I don't know. But I will tell you, a lot of you have hit this because you've copied like a good skirmisher. You've copied the code. You've done your reading. You're banging your head against the wall, and now you've moved on from easy mode to hard mode, and you're digging around in WASM code, and you've left the simple things behind. When really it's quite simple. The key is kind of unwrapped right here. And if you look carefully, we are unwrapping it as an smart contract value symbol. But if we recall, inside of our terminal here, I'm going to have to call it again. And if I call it again, I'm pretty sure it gives us a new key. But we'll go ahead and do it. Nope. Where did I call this? Did I call it here? Yes, right here. Oh, this isn't actually going to set it. This is just going to call it again. Haha, I am a genius. Inside topics, it's bytes. Smart contract bytes. Bytes M. So it's not a symbol, it's bytes. And so I think I'm probably going to stop here and say this is where the issue is. You're converting a bytes array as a symbol and turning that into XDR when you need to not do that and do what the event told you to do, which was use bytes, bytes, bytes. So if you can figure that out, and I'll give you one more hint. If you're looking for what it might be, when in doubt, don't ever get more smart than good old console log, because this is going to give you all kinds of wonderful information about things like, I don't know, SCV bytes, which may prove helpful in your endeavors to solve Skirmish 4. Okay, I'm not going to go any further. If you're still running into issues, good luck. We can solve those problems. Hopefully that these docs have actually been updated so that this actually will return values. I know I've solved it and some other folks have, so I have a feeling that something's working, even if the docs aren't perfect. Good luck. Do we have any questions, comments, anything else besides this? Yeah, so there's an interesting one from Bjorn, about, since it was called topics, I don't really understand why in the notes you called it key. Yeah, so storage, it's a key. In the events, it's a topic, which is still, I think, an interesting way to call events. I mean, the events don't have keys, so I guess it makes sense that they would be topics. But when you're looking up events, you've got these like filters which will look through all of the topics. These events are pretty cool because you've got these like array of, you can put in all kinds of different keys. It's almost like when you have a a key value database, and you can use like colons or slashes to denote like directories, and you actually use the key name, and then later on you will prefix to sort of say, I want to grab these pieces, or I want to filter the database response by these particular values. You have that built in with events where you can basically say, I have several different pieces. So it's a transfer, and it's a transfer from or to a specific account. And so if you want to find all the events that involve a particular account, or only transfers from or to a specific account, or you can do that by including these stars, which is like everything. So find every single event that matches transfer. This would be find every single event that matches transfer, probably to or from this account. And this would be find only transfers that are specifically from and to these accounts. It's just a pretty powerful way to filter out events. In our case, we're only using the one topic, and that topic happens to be the key for the storage value that you're looking for. So anyway, I see no other questions. Good luck. May the odds be ever in your favor, the force be with you, whichever you subscribe to, and prepare thyself for Skirmish 5, because in the words of RWX, yikes. We'll catch you all later. Good luck. I'll see you in the chatter channels. Have a wonderful rest of your day.